I'm visiting the Etruria Industrial Museum, home of Shirley's Bone and Flint Mill, established in 1857. It's also known as the Etruscan Bone Mill. I'm starting my visit from the car park built on the site of the original basin and wharf, from where goods were sent by water to various local factories, or by horse-drawn tramway to Hanley. The footbridge from the car park crosses the Caldon Canal and was installed to replace the original lift bridge. I'm now heading for the modern visitor centre, through which I'll be able to gain access to the Bone and Flint Mill. The museum is a well-preserved example of a 19th century steam-powered potter's mill, built to grind materials for the local pottery industry, and is located between the Trent and Mersey Canal and the Caldon Canal. Its position next to a canal is not unusual. The Chedderton Flint Mill on the Caldon Canal is another example. This particular mill is the last remaining operational steam-powered potter's mill in the world. When it closed in 1972, it had been in continuous use since 1857. The development of porcelain began by the Tang dynasty in China between 600 and 900 AD, and was further developed by the Ming dynasty in the 14th to 17th centuries. In 1748, Thomas Fry produced bone china, a product similar to porcelain, which became an English industry standard. Later in the 18th century, Josiah Spode further developed the process at his Stoke factory, making a commercial success of a strong, fine, white, translucent material made with 25% china clay, 25% flint, and 50% bone. The flint and bone had to be calcined, that is, roasted, then ground to a fine powder before mixing with the clay. Originally, a dry grinding process was used, but in 1726 a wet grinding process was patented, and in 1757, with the help of James Brindley, a well-known canal engineer, a safer wet process was established at specialist mills. Shirley's Bone and Flint Mill was such a mill. Jess Shirley, with his brother Joseph, had inherited the Bourne and Hudson bone works from his stepfather in 1852, and Jess went on to build the present mill in 1857. Road access was poor, but he had chosen a site between two canals where wharfing was available and easy access to local potteries. The mill was decommissioned in 1972 because of site problems, high running costs and environmental pressures. The business was transferred to a new grinding facility. Everything was left intact on closure, and after restoration by volunteers, which started in October 1978, it was officially opened to the public as a working mill by Fred Dibner on 6 April 1991. Occasional demonstrations are given in steam. Originally, the crusher room floor was level with the canal wharf, but mining subsidence lowered the whole area by about 6 feet, so is now entered down steps. Cornish stone was unloaded from boats onto the wharf. In this picture, taken prior to the subsidence, we can see bags of stone waiting to be crushed. The crusher was installed in the 1930s after the calcining kiln was decommissioned. It is of the oscillating jaw type built by Mason Brothers of Leicester, belt driven by a small horizontal steam engine of unknown manufacture and date. It is used to crush oversized flints and Cornish stone. Once crushed, the stone was wheeled into the gear room using the circular twist plate set into the floor. This enabled fully loaded trucks to be manoeuvred more easily. From the gear room, materials for grinding were winched up into the pan room via the trapdoor in the floor above. Power from the beam engine, named Princess, is carried via the gears and shafts in this room into the grinding pans upstairs. The main drive pinion turned both of the larger gears on either side of it, but the gear to the left is now disengaged, meaning no power is carried along that side of the mill when in steam. From the large outer gears, long horizontal shafts run down either side of the room. Each carries 5 sets of bevel gears. Materials like bone and flint were ground in water to minimize the amount of dust in the air and helped reduce lung disease, known locally as potter's rot. The ground material needed to be separated from the runny mixture left behind, known as slop. This was directed down wooden chutes either side of the gear room into circular washing tubs, as seen here. The mixture was agitated and then pumped into brick settling arcs. An arc is another name for a tank. Ground particles fell to the bottom of the tank, and the clear water above was drained away by removing wooden plugs at the tank's end. This left a thickened slop, which could be put into barrels and delivered to customers or pumped to drying beds. A pulsometer pump took the thickened slop away to be dried on heated drying beds, and once hard would be sliced into conveniently sized blocks for transportation to the pottery factories. Raw materials such as bone and flint have to be processed before they can be added to clay to manufacture pottery. Bone was initially sourced locally, but as demand grew, the net widened across the UK and then abroad. The flint kiln was used for calcining, or should I say roasting flints, at a temperature of up to 1000 degrees centigrade. Filling the kiln was a skilled job. 100 weight of coal was used for 1 ton of flint. It would combust between 8 and 16 hours and then be left to cool before being removed through draw holes at the bottom. Production of ground flint ceased in the 1930s. Princess is a double-acting, condensing, rotative beam engine to the design of James Watt. Purchased second-hand and installed when the mill was built in 1857, she is thought to have been manufactured by Bateman and Sherritt of Salford, Manchester, in the 1820s. The flywheel is 20 feet in diameter and 10 tons in weight. The axle extends through the wall into the gear room. Steam is generated from a Cornish boiler built in 1903 at the nearby Cliff Vale Boiler Works. It is hand-fired with coal and contains about 2,500 gallons of water, indicated in 2 water gauge frames. The safety valve releases pressure at 60 pounds per square inch, although the boiler is operated at about half that pressure. Water is fed to the boiler from a large iron tank in the roof. It was originally pumped in against boiler pressure by two Weir steam pumps, similar to the ones seen against the side wall. Electric pumps are now used. Bone was treated in a similar way to flint. After being boiled to remove tissue, this produced glue, a saleable byproduct. In this instance, wood was used as a fuel because bone is more combustible and is prone to contamination from the iron pyrites in coal. Material to be ground, having been hoisted through a trapdoor in the floor from the gear room below, was tipped into one of 10 pans and water added. The pans vary in diameter from 6 to 12 feet. The larger pans are closer to the steam engine, obtaining maximum power to drive their heavier load. The pan floors are composed of chert blocks. Chert being a hard, dark, opaque rock composed of silica. Power from the floor below rotates sweep arms which push large chert blocks, or runners as they are known, around the pan, which tumbles the material and grinds it to a suspension of fine particles. After about 8 hours for flint, less for bone, the material could be run out of the pan to the floor below for further processing.